Okay, this is really testing your understanding of the chain rule. By the way, this should have been dy dx. Uh, when we take the derivative of this expression, we're going to be taking the derivative of f of x squared minus 1. Even though we don't know what f looks like, we can find out what the derivative of y with respect is over here. Just to give you the idea, if y is some function of x squared minus 1, then the derivative by the chain rule is f prime of x squared minus 1 times the derivative of the inside, which would be 2x. Okay, so that's what we're going to apply over here. Now, if you can visualize this with an exponent of 1/2 instead of the square root symbol, applying the power rule, I'll use y prime instead of dy dx. Bring the 1/2 down front, reduce the exponent by 1, and then multiply all that by the derivative of this inside function. The derivative of x is 1. The derivative of this term right here comes from what we did over here, f prime of x squared minus 1 times 2x. Okay, and now we can rewrite this, substitute 3 wherever there's an x, and evaluate. So we'll bring the negative 1/2 power to the denominator and rewrite this as a square root symbol. And then wherever you see x, we'll replace it with 3. So when I put 3 in for this x for x squared minus 1, that's where this 8 comes from, f of 8. And same deal here. 3 in for x, f prime of 8, and 2 times 3 gives us this 6. And now let's simplify. So here, f of 8 we're given is 0 from right here. That gives us 1 over 2 times the square root of 3 for this factor. And over here, f prime of 8 we're given as 3. So 3 times 6 is 18, plus 1 is 19. And then we multiply numerator and denominator by the square root of 3 to rationalize the denominator. 19 radical 3 over 6. That should be your answer. There you go. Hope that helped. If you have any questions, post a comment.